Right, so to use exponent, so I've got to get rid of this 5, and to do that we just divide. So we get 8 to the 4x plus 1 equals 41. Now I'm going to take a log of both sides. So log of 8 to the 4x plus 1 equals log of 41. My exponent can come out in front, and so we'll move over here. We got 4x plus 1 times log of 8 equals log of 41. First, I want to get rid of my log, so I'm going to divide by log of 8, but I'm not actually going to use a calculator yet. We'll wait and do that at the very end. So I get 4x plus 1 equals log of 41 over log of 8. So to get x by itself, I'm going to start by subtracting 1, and then I'm going to divide everything by 4. So that's a lot of steps. We're just going to do them one by one in the calculator. So to start with, I'm going to do log 41 divided by log of 8. So the log button's next to 7. So log 41, close your parentheses, divided by log of 8. So I get my answer, this long decimal. I'm just going to leave it there and subtract 1. Then I'm going to leave it there and divide by 4. So I get 0.196. Okay, we also looked at interest problems. So our interest formula is A equals P times 1 plus or minus R over N to the NT. So remember, P is your starting amount every time. R is your rate, your interest rate as a decimal. N is the number of times it's compounded each year, and then T is your time. So Jamie deposits $500 into account. So that 500 is my p-value. So I'm going to go ahead and write that in as my p. That earns 1.5% interest. So I'm going to move my decimal 2 over to get 0.015. Compounded quarterly. So I've got 1 and it's earning interest. That's plus 0.015 divided by, now my n, because it's quarterly, is 4. And that's to the 4t, but my t is going to be 3. Because it's in 3 years. And then I'm just going to type all this into my calculator. So I'm going to start with the 0.015. Move this over some. So 0.015 divided by 4 plus 1. Alright, and then I'm going to raise it to the 12th power, because that's 4 times 3. And then times it by 500. So after 3 years, she's got 522.97. Right, Rocco bought a car for $18,000 and it depreciates, that's going down, at a rate of 4.2% each year. So my $18,000 is my initial amount, and I'm depreciating, so I'm going to subtract, and then 4.2 would be 0.042. Right now, because it's each year, that's annual, so my n is just 1, so I don't need it anymore. Because if you divide by n or multiply by, or divide by 1 or multiply by 1, it's the same thing. So 1 minus, and I'm going to put 0.042. Now, this one wants to know how long before it's worth half its value. So I'm looking for the time. So I'm going to put to the t. And I'm going to set this equal to half its value, which would be 9,000. Now, you can solve this any way you want, but I choose calculator. Let the calculator do the work for me. So I'm going to go with my calculator. I'm going to go to y equals, clear out what's in there. I'm going to put 9,000. Oops. And then in y2, I'm going to put in 18,000, and then in parentheses, 1 minus 0.042, caret, I'm going to put x instead of t. Now, this 9,000 and 18,000 is a really big number, so I'm not just going to press graph yet. I'm going to go zoom, and I'm going to go all the way down to 0 where it's zoom fits, and just let it load. Remember, as long as it's moving, it's loading. So it's going to take a little bit. And we just want to see the intersection in our graph. So if I can't see it, which it's done loading, I can't see it, I'm just going to zoom out one time. So zoom 3, enter. Alright, there's my horizontal line. Here's my exponential. My intersection's right in here. So once it's done, I'm going to go second trace 5, enter, enter, enter. Let it load. and we get 16.15 years. Okay, solving logarithms, we use all different types of properties. Alright, so for this first one, I have the log of something equals the log of something. Because it's both log base 10, I don't need the logs. So we get 4p minus 2 equals negative 5p plus 5. And I need to get my p's on the same side, so I'm going to add 5p. So we get 9p minus 2 equals 5. Add the 2 over. 9p equals 7. And divide by 9. Can't divide it, so I'm going to leave it as 7 over 9. Right, for the second one, I've got just the log and my variables inside, so I'm going to have to put it in exponential to be able to solve negative 2. So I'm going to divide both sides by negative 2, and we get log base 5 of 7x equals negative 1. So now I'm going to write it as an exponential, so 5 to the okay, divide by 7. Now, I could write 5 to the negative 1 as 1/5 or use the calculator. So in the calculator, I'm going to get out of my graph here. I'm going to type in 5 caret negative 1 and then divide by 7. Alright, now it's going to give me a decimal. I want a fraction. Math, enter, 1 over 35. Alright, and the last one, I have 2 logs on this side that I'm adding. Adding means multiply. So we're going to say log of 8x equals 2. Again, just like before, my x is inside my logs. If there's nothing there, that means I have base 10. So 10 second power equals 8x. Right? Second power is 100. Divide by 8. 100 divided by 8 simplifies to 25 over 2. And we'll leave it as a fraction. We also graphed logarithms. Alright, so remember to graph, same thing, we look at that parent function without the h and k. This h is going to tell me to go right 1, and this k is going to tell me to go up 1, but we'll get there later. So I'm going to start with y equals log base 3 of the x, and I'm going to flip my x and y. So x equals log base 3 of y, and then I'm going to write it as an exponential. So I start with my base, go around the world, and then come back. So I'm going to make my table for 3 to the x. Okay, you're going to have a calculator, so if you can't figure this out, 3 caret negative 2, enter. I don't want a decimal, so math, enter. So we get 1/9. Okay, do it again if you need to, but 3 to the negative 1 is 1/3. 3 to 0 is 1, 3, and 9. Alright, now I'm not going to graph these because this is for my exponential. I need to switch my x and y back. 1/9, negative 2, 1/3, negative 1, 1, 0, 3, 1, 9. Now I'm going to graph these points. So over 1/9, down negative 2 is right about there. Over 1/3 is a little more. Negative 1, 1, 0, 3, 1, and then 9, 2. I'm not going to connect these points because I need to go back to this right 1, up 1. So I'm going to take all these points and go right 1, up 1. Right, my asymptote is a vertical asymptote for the logarithm, and it's going to be my h value instead of my k. So remember, it's a -1 here, so my h is really a positive 1. For exponential, your domain was all real numbers, but for range, we flip it, or for a logarithm, we flip it, and your range is all real numbers. And my domain will be 1 to infinity. And then we looked at natural log and base e. Right, so to solve this, I'm going to take a natural log of both sides. So 4x minus 9, keep it in parentheses, times natural log e equals natural log 56. Natural log e goes away. So 4x minus 9 equals natural log 56. Add my 9. 4x equals natural log 56 plus 9. Divide by 4. and use the calculator. So natural log 56, close that parentheses, plus 9, enter. Then divide it by 4, enter. So we get 3.26. And the last thing we looked at is the compounded continuously. So as soon as you see continuously, you got to be thinking PERT. P-E to the R-T. Alright, so you deposit 600 into your account. So we've got 600 as our initial amount, E, and it earns 4% interest, which is 0.04 to the T. So there's my equation for this scenario. I want to know how much money that is in the account after 5 years, so I'm just going to plug in 5 for T. So in the calculator, 600 times E, which is second natural log, and then 0.04, and times, and we're typing in 5 years, and I'm going to close my parentheses, equals, so we got $732.84. And we don't have time to worry about this question, which isn't that big of a deal. Just remember A equals PERT.